Hi, everyone. I'm with Dr. Tom Sugar from the Wearable Robotics Association, and I'm Bobby Marinov from the Exoskeleton Report. And today we're going to talk about the applications to exoskeletons, starting with industrial and occupational devices. Hi, Tom. How are you doing?
I'm doing well. Thank you, Bobby. So today we talked once already about the different categories of exoskeletons. So today we were going to focus on industrial or occupational exoskeletons.
So thanks, Tom. Right. Last time we talked about how we can categorize exoskeletons, but we purposely tried to avoid applications and how they apply so that we can do a deeper dive on each one. The main categories right now that almost everyone uses is consumer and recreational exoskeletons, industrial or occupational, medical, which can be either assistive, augmentative rehabilitation, and then defense and military. There can also be other categories and other major application fields, but for the time being, these are the major ones. So today, I think we can focus on industrial. So on the Exoskeleton Report, we've currently captured more than 100 occupational exoskeletons that you can either buy based on your geographical region or they're close to being released. And we further subdivided that into major applications, which is arm and shoulder support, lower back and back support, leg support, power gloves, and tool holding exoskeletons. So Tom, I'm hoping that today we can go through each one of these 5 categories and just talk about our experience with specifically what is it that these devices can do for people and what have we seen them be used for?
Sure. So if we think about these, again, if we think about these exoskeletons, they are typically used to reduce fatigue, to help you perform a task in, let's say, manufacturing or logistics. So let's pick arm support first. And so arm support, there's about 34 commercial devices, let's say, in arm support. So if we pick, because we'll talk about this first, let's pick arm support exoskeletons that are passive. And so we talked about this last time, where passive exoskeletons typically use springs or fabric systems to support the movement. So now if I pick on passive, I'll have 27 results in arm support exoskeletons that are passive devices, like Hapo Up. So if I pick this device, it is now a passive exoskeleton. It's using passive elastic, typically springs, or they'll use elastic rods to support the arms. So if you're working above your head, you're doing repetitive work, let's say above your head, these devices would be quite useful. Because we all know, let's say when your arm's above your head and you're trying to put a light bulb in a socket, you're trying to use a wrench above your head working on a car, your arms start to fatigue. And so these devices are just supposed to help. Any other thoughts, Bobby?
Oh, yeah. I think we're just getting started here.
Yeah.
So in a nutshell, we call it arm support, but predominantly they're focused on the shoulders. And the shoulder is the most complicated joint in the human body, with more than 5 separate degrees of movement and rotation. So you really don't want that get injured. Once you get your shoulder injured, going through the physical rehabilitation, getting your full mobility back is going to be expensive and it's going to be time consuming. So these devices are wearables, but they don't just beep and chirp when they think that you are overexerting your shoulders. They immediately try to offset some of that weight and some of those forces that your shoulder might be experiencing throughout the workday, with the goal of not taking off all of the weight and strain off of them, but to take off some of them, some small percentage. So then you go home at night, your shoulders, your shoulder muscles, your ligaments have the time to recover. So you go back fresh to work, and you're not building fatigue over time, which accumulates and accumulates and accumulates until you have a critical injury and you have a failure, and now you have a shoulder injury that will linger with you for the rest of your life.
Yes. And so I want to make a couple extra comments too, that these devices being passive, typically there's springs holding your arms up. And so you do have to, sometimes, not all of them, but sometimes you have to work against them to bring your arms down. So what we have been hearing is that these devices typically work well when you have tasks where you have to have your arms above your head in a, let's say, a static pose, and you're there for some time. If you have to go up, down, up, down, up, down really quickly, maybe they don't work as well. Any thoughts on that?
Yeah, we absolutely need to do a separate episode which just focuses on matching the exoskeleton, or it might not be an exoskeleton, it might be some other ergonomic solution to the task at hand. But absolutely, you have an excellent point that there are some drawbacks to using these devices, which could be again a separate video all on its own. Like what is the cost that you pay for trying to have an exoskeleton to complete a work task? But I think we should focus on like where have we seen these devices and what we know about them. For example, I think one of the important things to mention is that it needs to be a continuous repetitive work task. It would appear that 1 to 2 hour work cycle is required for you to really start to feel the benefit of the exoskeleton. So like, where can we find these 1 or 2 hour work cycle? Imagine that you are installing sprinkler heads on a brand new warehouse. This could be 10,000 sprinkler heads, and now you're going installing, rotating, next one, installing, rotating, welding, whatever it is that you need to do, seating, next one, installing, welding, seating. Where I live, they had to redo some of the window casings with cement, and I just was watching the workers on our raised platforms, and they're just going through the cement over and over and over, eyes up, arms up, eyes up, everything just up, 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 up for hours. Some other applications where we've seen for this is doing surfacing with power tools on ceilings and walls, where not only do you have to hold the tool up and you're grinding and cleaning up the surface for potentially hours at a time, but also the amount of pressure that you're applying matters. So it has to be consistent pressure. Yes. Tom, where have you seen these type of devices really find a home?
Yes, so people are using them in construction. I've also heard about welding. So think about welding where maybe your arms are above your head and you have to weld a straight line. So there's been some, and we'll talk about this later in another show, but people are thinking about that the quality of the weld has been improved because over time, can I still draw that straight line? I've heard about painting. There was a painting contest where you were supposed to paint a straight line, and some people were using an exoskeleton and some people weren't. And after, 20, 30, 40 minutes, you could still paint a straight line, let's say. But I think the shoulder exoskeletons would be useful in automobile manufacturing, would be useful in construction, would be useful in welding, would be useful in tasks above your head. So I think those would be some of the good ones.
Yeah, and the key is that it has to be a repetitive, continuous task. I think when you mean welding, you're probably referring to what we've heard from Toyota, where the car would go through the robotic welding, but then it would be suspended above the head of the employees, and they have to do spot checks and weld checks. And that is a 4-minute cycle time for each vehicle where they are up working like this with the heavy welding tools. And they love, we've heard nothing but good things about departments like that. I think another example was just at Wearable Europe, was from, I think, a train depot maintenance where they're working over giant locomotives with 20-pound tools. And some teams didn't like the exoskeletons. Some teams would refuse to even go to work without their shoulder support exoskeletons. So why don't you show us the powered ones? How are they different now?
So let's think about powered exoskeletons. So like on a powered exoskeleton, like let's pick this one. You can imagine that you have a pneumatic air source. It could be motors or it could be pneumatic. This one, I believe, if I'm correct, is pneumatic. But if I have a pneumatic system, then I could have an exoskeleton that could turn on, support the arm when I need it, and then turn the air off when I don't need that support. And
so you don't have to fight the device like you alluded to.
Right. You don't have to fight a device like that I alluded to, like a passive device. So these devices are quite interesting, state of the art, and I think you'll see some powered systems out there in the marketplace.
Yeah, but to be clear, the passive devices are also state of the art. They have state of the art materials, state of the art elastic elements. Now we finally have access to 3D modeling and being able to simulate these exoskeleton devices on people, on simulated people, so you can estimate what are the reaction forces without having to necessarily rely just on dummies and EMG signaling. And that should be another topic, which is how do we evaluate exoskeleton technology? I think we've done shoulder exoskeletons. Yes. Why don't we move on to the next category?
Right. So let me go back. I think we went to an exoskeleton catalog, and then I did industrial. And so we talked about arm support. So let's go to back support. And so obviously there's a lot of exoskeletons in the back area, because all of us, as you get older, can have back pain. So you can imagine then back support exoskeletons that are passive and powered. So I want to go to the passive exoskeletons first. And I think we talked a bit about this in a video that we just did, where if I have a passive exoskeleton, basically as you squat down, you charge the springs or you charge the device or you put energy into the device, and then that exosuit or that exoskeleton helps you to stand back up. Also, these devices, and I'll let you make that point, Bobby, can redirect the forces so that it really helps the back. So I think we picked last time, and we'll pick again. We'll pick some different devices, but we picked the Apex last time, where you have what they're calling an exosuit. So you can imagine these elastic bands. I'm going to call them elastic bands, and then when you squat down, you stretch those bands, and then when you stand back up, they give you energy. More importantly, and I'm going to let Bobby discuss that, these bands, they have a different moment arm. So, you're changing the moment arm. Instead of your you're squatting down and your back is here, you might have an extra 3 or 4 inches to the moment arm to these devices.
But that's an excellent, yeah, absolutely. That's an excellent point. And maybe we should have even talked about that with the shoulder support exos, but it's exactly the same idea. An exoskeleton doesn't just take the force and move it from one body part to another body part. It really boils down to reducing the moment time. So in a nutshell, if you have a heavy object that's close to your chest, it takes you one amount of energy and muscle activation to hold it. The further it goes away from your body, you are generating a moment time. And that can be a shoulder support exoskeleton where you're holding something in front of you, or it could be a back support exoskeleton where you're bending to do a task in front of you, and now your own body is generating that moment time.
Yes.
With these exoskeletons, be it passive or active, we can redirect the energy and reduce the moment time itself. So we're not just transferring energy from one body part to another, we are actually reducing it. So one way to think about it is the simplest way is you have that heavy weight in front of you, you just put a stick underneath it. The weight hasn't been eliminated, the moment time has been eliminated. You and I have been talking about exoskeletons for decades. I finally got to try one. We had a big party at home, and there were dishes for 20 people to clean. And I'm a little bit of a taller person, so our sink counter is kind of low. So after 20 minutes of cleaning dishes, I'm bending forward, my back starts hurting. All of a sudden, it dawned on me, wait a second, I have an exoskeleton. Let me just put it on, tighten it, and lo and behold, I did 1.5 hours of cleaning dishes without feeling any sort of pain in my back.
So where are we seeing these exoskeletons be used? I'll give a couple of examples. In logistics warehouses, like, right? So in logistics and warehouses.
Well, can you expand on that picture, Tom? I actually want to talk about that. If you hit on the top right corner, that zoom button. So when we talk about logistics, you always hear lift properly, lift with your knees. And that's absolutely correct. Lift with your knees, have the load as close to your body as possible. That way you're limiting the moment time. But I've worked in manufacturing for 15 years. This is a great picture and a great example where you can have a cage or you can have shelves. In the real world, you have things that are blocking your knees. You cannot do the proper ergonomic lift. That is just not feasibly possible in your work environment. You have to bend forward to stack, move, get ready to transfer items and supplies in or out of your operating area. It could be a patient transfer, or it could be an inanimate object like a box or raw materials, finished materials. You just can't. You cannot do the proper ergonomic lift. And what we're doing is we're destroying people and destroying their backs to get the work done quickly. And after that, we're done with them. And we say, we are so surprised that they got injured. And we know that back injury and lower back injury is the number one source of physical injury, and in most cases, the number one source of lost work hours. Anyway, be it in the developed world or anywhere else. It doesn't matter if it's North America or Europe. And this picture captures that, where you can have a cage, you can have something. That's where a back support exoskeleton comes into play. It's a physical device that safeguards your back.
Yes. Yes. And so we've seen these devices being used in warehouses. How about you're just leaning over and you're sorting mail, right? So you're in a place, you're leaning over, and you just have to, some boxes go this way and some boxes go that way, and you just have to lean over for a couple hours. And we all know that that's painful. You could see some examples of people helping in caregiving. There's examples of people working in construction. Those are some of the passive ones. Maybe we'll also talk about the powered ones. So you can then imagine that instead of putting elastic elements, we could design motorized systems. So we could have motors at the joints to assist you. And so the advantage of that is, I think I said this in the previous video, is that motor could slow you down and resist your movement as you go down. So to help you get down into a squat or help you get down into a chair. And the motor could then turn in the opposite direction and help you get back up. And then the motor could turn off and be transparent, and then you could walk around and not feel the exoskeleton at all. Any other?
As well as, you can run metrics off of the motor activation. You can change the settings and the spring constant on most of the passive ones. With the powered ones, you can usually do that with the switch of a button, depending on the user interface. You can change and customize behavior and activation. I think we're just only now beginning to really touch the surface of how much customization should be allowed to achieve that transparency and to make it feel like the exoskeleton is part of your work kit.
So,
I want to give another example. I had a company come over with a prototype, and they're like, well, we designed this back support exoskeleton specifically for a transfer of luggage at airports. And we moved some furniture around to simulate a cart that has just brought in the suitcases, and they had a suitcase with them, and I moved it on and off, back and on, and that's it. Everything was fine. And they're like, okay, Bobby, good job. Now, to the suitcase that's on the other side of the luggage cart. And I'm like, what other side of the luggage cart? And if you look at pictures of airport luggage carts, they are actually stacked side by side. There's luggage that's on the closer side towards the airplane. There's a whole other stack of luggage that's on the far side. And once I started bending forward, because we rearranged the furniture so my knees cannot go through what would be the delivery cart, if I didn't have that exoskeleton on me, I would have definitely blown my back. Like those angles, how you need to reach forward to grab suitcases that can be 40, 50, 60 pounds again and again and again, they're insane. I was so happy that I had an exoskeleton on me.
Right. So you can imagine, I'll end on a couple last words. You can imagine systems, again, with springs to help you lift boxes. You can imagine, again, on powered. I wanted to show one last powered system because I thought it was kind of unique.
Sure, go for it.
One powered system. So the JPET has a system where they've got a powered system that helps to, I would call it, release the pressure on the spine. Hopefully I'm saying that correctly, but it's a robotic lumbar belt that feels really good, and it helps to release the pressure on your spine, let's say, when you're walking around. And the nice thing about it is because it's robotics, I'm going to call them actuators. The robotic actuators will go up and down and move with you. So that's a nice, unique device.
Yeah, and I got to try out both the initial prototype almost half a decade ago now, and I got to try the newest version last October. And yeah, it felt good. So it's 4 motors, 2 in the front, 2 in the back, and it lifts up your entire core, and it can potentially alleviate some of the pressure forces from the spine directly. And it stays with you as you bend forward, back, and side to side.
Right.
All right, what's next, Tom?
So let's see what's next. So if I go back to the catalog, I do industrial. Let's talk about leg support systems. So on the leg support systems, I think of a lot of some of the chairless chair systems. So you can imagine that you have a system where in industry, maybe you're not allowed to have chairs in that industrial section, but you need to, walk a little bit, sit down, work underneath the car, then stand back up, walk, grab a couple more parts or a tool, come back over, sit down and work. But when I think of some of these leg support systems, I think of some chairless chairs. What do you think, Bobby?
Yeah, chairless chairs are absolutely one of them. And we've also seen chairless chairs in surgery rooms now, where it could be a 2-hour, it could be a 12-hour surgery. Obviously, you can be moving chairs and stools around. So some surgeons, especially ones that already have some degree of back or leg injury, absolutely swear by these, as they can sanitize it. It goes over their scrubs, it can go under their scrubs, and they can be more comfortable, have less fatigue, less pain, and be more focused on their patients. And I had 12-hour surgery just 2 years ago, and I definitely want my surgeon to be focused on me and not on any discomfort that they're feeling from standing up for 12 hours.
Right.
And another subcategory that we are seeing become popularized is ones that are for squatting and kneeling. So they will lock up to move a lot of that fatigue off of the knees. You're squatting for a long time, you're kneeling for a long time, whatever the task that you're doing. It could be in, again, farming, manufacturing, construction, logistics. It's a way to reduce fatigue, move some of the forces, some of the torque away from your knees. And finally, the last category that we are seeing is what's called gravity compensation and gravity redistribution devices. And Tom, you've actually worked on one of those, come to think of it.
Yeah, are you thinking about the ones that are trying to take like a backpack and transfer the load down to the ground, or so?
Yeah, precisely. Some of them are tool holding ones, which is kind of like an older category, and we'll get to that.
Right.
But there's now some that are emerging which just try to hold the weight of your kit. It could be a backpack, it could be some sort of a heavy tool or something that you're carrying potentially. It could be for first responders, it could be like an oxygen cylinder.
Right.
So we are seeing a re-emergence of these type of devices as well, which go around the legs and try to drive some of the force and some of the weight directly into the ground.
Right.
And we call those tool holding exoskeletons if they have an extension to hold something like a grinder or a heavy welder arm. Maybe we should click on those.
Yeah. So if I go, that's what I was going to say. So if I go back to the catalog in industrial tool holding, some of the tool holdings, let's jump to tool holding next. Some of the tool holding ones are some of the ones I'm thinking about. Some of the original devices, let's say by Lockheed, where you have an exoskeleton and you want to take that load and bring the load down to the ground. And then you have a zero gravity arm that's holding typically a quite heavy tool. These tools can be 30, 40 pounds. Some of these devices, again, had, a zero gravity arm holding a tool. and then some of these devices behind them would have a counterweight.
I think zero gravity arm is trademarked, but we can call it a spring-loaded arm.
Sorry, yes, a spring-loaded arm, excuse me.
It can be a spring-loaded arm. It could also be a crane or a motorized or even a hand-operated lift tool that suspends some sort of a heavy tool. Well, typically we've seen grinders, like at a Navy dock. You could need to clean the hull of a boat, and that's something which is grinding continuously. We've seen in construction, a famous example would be breaking down concrete.
Right.
So you have a power jack that's against the wall, or it needs to either point up or point forward. So again, that the whole point is to take that momentum and to redistribute it, so it is less force and less fatigue on your body.
Yes. Yes. So again, if I go back to the catalog, and industrial, these leg supports and tool holding, either we're thinking about chairless chairs, or typically you have leg support devices that'll hold tools. So maybe let's go to the last category, power gloves. And so under power gloves, basically, people have been thinking about how do you enhance the grip force? Because what I didn't realize, and I started doing some research on this, was your hands can grip something pretty tight, but they can only do it for a short amount of time before your hands start to fatigue. And so you'd like to build a device where you'll have motors that can help with the grip strength. And more importantly, if you have to hold something for a long time, again, this idea, if you have a task where you might have to hold something for 4, 5, 6 minutes, and basically these tools can help to reduce fatigue and strain injury.
Yeah, and that's really well said. And this is true for the vast majority of these occupational and industrial exoskeletons. Is, yeah, they could be used for you to grip tighter, but 99% of the time, the idea is to help you maintain that grip or maintain that task. So you're able to do a task for longer with less fatigue. So in this case, a lot of these power gloves help you grab onto something, and then they kind of lock into place, so you can almost relax your hand a little bit and let the exoskeleton take over in maintaining that grip, in maintaining that strength. So now you're not fatiguing your arm and hands as quickly, because you're not the one providing 100% of the force to hold on to the tools that you're holding on to. And then when you're ready to let go, you pull against the glove, and it knows, its controller understands that you're ready to let go, and it terminates the assistance.
And I think I want to make one comment here. I believe the Iron Hand now is being offered and sold by Skelex. So I'll just make that one comment.
Sure.
And we'll update the catalog, but I just want to make sure that we try to give the most reliable information as we can. So
thanks for doing that. Yeah, updating all of these resources is a never-ending challenge.
It's a never-ending challenge. And again, I think I said this in the last video. Thank you, Bobby, for putting together this outstanding catalog, which can show people what is possible, what is being used, what is being sold. So if we go back to the occupational market, you can imagine systems for the shoulders and arms, imagine systems for the lower back, Imagine systems for the legs and leg support so you can hold heavy tools. And then imagine systems for your hands and with the power gloves.
And those are just the main categories. New devices coming on the market almost on a weekly basis.
Right. Any other thoughts, Bobby?
Oh, in a nutshell, exoskeletons, occupational industrial exoskeletons are real. They're already being used primarily in West Europe.
Yes.
We are seeing some use in Japan and Korea. North America is using them, but maybe lacking a little bit compared to the hotspots. They are beginning to prove themselves as being effective ergonomic solutions when being applied properly. I think we can definitely do a separate episode on how to match, hints and tips on how to match an exoskeleton device or a different ergonomical solution to a specific work task that you're having. There's also some drawback to using these to be aware of, which there's also some myths and misconceptions, which deserves a completely different time segment. At the moment, there unfortunately isn't a single source where you can just click through it and see every single exoskeleton application that is proven and tested. Like, let's say you're doing mining, for which tasks in mining do we know exoskeletons are used for? Let's say you're doing construction, exactly where in construction are they used for? So we don't
be a fun extra section to Exoskeleton Report, actually, which would you could pick a construction and then show exoskeletons being used in construction or something like that. That would be fun to think about, Bobby.
Yeah, because it's all, at the end of the day, it's all in the detail.
Right. I would like to add one last thing. If you're also interested, and we'll have to do another section, another video on this, but if you're interested in exoskeletons being used in the workplace, Urs Schneider at the Fraunhofer Institute has an exo workathlon, and he has designed tests for overhead work, for shoulder work, for back work, for work in two people doing work in construction and welding. And he is showing exoskeletons being used in industrial applications. And what I like about his work is he's been trying to show that they're useful, they're being used, people have less pain. He's got questionnaires, and also that he talks about quality. So you're not asking people to do extra work or anything, but the quality of your work goes up because you're less fatigued and things like that. So,
and I'll add to that he's also tests these devices as a product family.
Yes.
Rather than individual, as he believes that if one works, then that whole product family should work, like a bicycle. You can have a mountain bike, you can have an electric bike, but a bicycle should be able to get you from point A to point B faster if it really works as intended. And he's been doing that, doing the testing as a product family and getting multiple exoskeletons from different developers, testing them and putting the data together and reporting on the averages.
So we'll have to do a deep dive on this website in another video, but I want to show people that people are really thinking about how these devices are being used in, let's say, box handling or let's say welding. And he has real workers with hundreds of people thinking about logistics or automobile manufacturer or welding. We'll have to do a deep dive on that. But I wanted to say this is work being done out of Europe that's outstanding.
Yep, so you get a little bit of a preview for
Yeah,
next episode.
let me go back to Exoskeleton Report, and there are the catalog and our industrial exoskeletons. Thank you, Bobby, for, again, a really fascinating and fun conversation. I enjoyed it.
Yeah, absolutely. These devices are being used. I hope that everyone that listens to this gets a little bit more understanding of where they're used, how we are talking about them, how we are categorizing them, and that this is just the beginning.
Thank you, Bobby. Have a good evening.
Thank you, you too. Thanks for listening.